Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over how to use the quotient rule. Alright, before we get started with some examples, we're going to take a look at the steps for applying the quotient rule. Okay, let's write this down, the quotient rule steps. Alright, so the first thing you want to do whenever you encounter a differentiation problem that looks like you have to use the quotient rule, the first thing you want to do is try to avoid it. Okay, try to rewrite the problem. Try to rewrite in order to avoid using the quotient rule. Okay, the quotient or product rule. Alright, so if it's possible to simplify it, you definitely want to simplify it and carry out your differentiation by term differentiation. Okay, alright, so let's say you rewrite the problem by carrying out different kinds of algebraic manipulations or trigonometric identity manipulations, and you're unable to avoid, you see that you cannot avoid the use of the quotient rule. So you then proceed to the next step, step 2. If it can be avoided, what you're going to do is you're going to proceed to label the functions u and v. Okay, label the numerator u and the denominator v. Okay, this is very important. Remember, the numerator is u and the denominator is v. Okay, now after you label the numerator and the denominator, this next step might not seem important, but it's really helpful to avoid making mistakes. You want to use your labels, your u and v labels, to write the quotient rule. Okay, to write the quotient rule. So basically, the quotient rule v u prime minus uv prime over v square, you use your u and v's just as labels to write out that rule first. Okay, when you write out that rule, then you avoid making mistakes when you're applying it, as opposed to applying it mentally to the functions in your brain. So after writing down the quotient rule using u and v, you now apply the formula that you just wrote. Apply the rule to the terms. So you know exactly what u is, you know exactly what v is, and you're not confusing yourself while applying the rule. And then lastly, simplify where applicable. Okay, alright, let's go ahead and take a look at an example. So the first question that we're going to do, let's say if y equals x to the third plus x squared divided by x, find dy dx. dy dx is a derivative of y with respect to x. Okay, so if you take a look at this problem, you say, oh, y is a quotient of two functions. The numerator is a cubic binomial and the denominator is a linear monomial. Alright, so oh, we have a quotient of two functions, so let's just use the quotient rule here. Okay, so remember the first step that we're advised to use is try and see if you can avoid using the quotient rule. Can you rewrite the problem in a simpler way? Okay, so let's go ahead and see if there are some algebraic procedures that can be applied here that will help us differentiate this by just simply using the rules and not using the product or quotient rule. Okay, so we have y equals x to the third plus x squared. Now, whenever you have situations like this, you can always decompose the algebraic fraction. If I decompose it, I'll have x to the third over x, which is of course to the first power, plus x squared over x, which is to the first power. And then when I simplify this, I'll have x to the, remember your properties of exponents. When you're dividing, you subtract exponents, okay? When you're dividing exponents with the same base, you subtract the powers. So 3 minus 1 is 2, and 2 minus 1 is 1. So our y function in a simplified state is x squared plus x. Okay? And now you notice that we don't have to apply the product or quotient rule here. We can just differentiate this using term by term differentiation. So y prime is x squared prime plus x prime. Okay, so the derivative of x squared, remember your power rule. If we apply that here, let me just put the rule on the side here. The differentiation rule that we're going to be using. If you have x to the n prime, you power down the power, x to the power minus 1. Okay? And also if you have a constant multiple, ax, in this case a is 1 prime, it's just like the slope of a linear function. Okay, the coefficient of x is your slope, right? So if you differentiate this, your answer will be a. So if we apply this two rules here, the derivative of x squared is 2x to the 2 minus 1, which is just 1, plus the derivative of 1 times x is just the coefficient of x, which is 1. Okay? So the derivative of y with respect to x is equal to 2x plus 1. And you notice we were able to differentiate this function without using the quotient rule. Okay? So anytime you're presented with a problem, before you start jumping into the quotient, product, or chain rule, always ask yourself, can I rewrite this so that I don't have to use any of those big three rules? Okay? Alright, let's take a look at another question. So this is a question that we're going to consider next. Let's say you were to find the derivative with respect to x of x plus 1 divided by x squared plus 1. Okay, so let's say this is the problem that you're to differentiate. Alright, so first things first, we want to ask ourselves what we're differentiating. Can we rewrite it in a way that we can avoid using the quotient rule or the product rule? So let's see. Now, one thing you want to note, one mistake that some might make when trying to rewrite or simplify this expression is as follows. One thing you want to note is that when you have x squared plus 1, sorry, let's do x squared minus 1, or x squared minus 1, this is a difference of squares. Okay, so whenever you have difference of squares, it can be factored into x plus 1 times x minus 1. Okay, now what if you have x squared plus 1? This is not a difference of squares. Okay, this is a sum of squares. So guess what the factored state is? Well, if you want to use integer coefficients, I don't want to use complex imaginary numbers. If I want to use integer coefficients to express this sum of squares in a factored state, this is going to be x squared plus 1. Ladies and gentlemen, this is a prime expression. It cannot be factored using integral coefficients. Alright, you have to use imaginary numbers in order to be able to factor this. But if you look at the numerator, there are no imaginary number coefficients, so you just want to leave x squared plus 1 alone. So what does that basically tell us? It tells us that we can't simplify this quotient. We cannot factor the denominator or numerator. Okay? So if we can't factor the numerator or denominator, which means we cannot rewrite in order to avoid using the quotient rule or the product rule, then we have to use the quotient rule here because we have a quotient of a linear binomial and a quadratic binomial. So we'll advance to step 2, which involves labeling. We'll label our numerator function u and the denominator function v. Okay, after you label it, write the rule using your labels first. So we have, let's see, uv prime, u over v prime is equal to v u prime minus uv prime over v square. This is the quotient rule. Okay? And there is a mnemonic device that some students use to remember what the quotient rule is. So basically, they call the numerator function high because it's above, and they call the denominator function low. Okay? So the mnemonic device is basically the derivative of the quotient of high over low is basically low d high. Remember, always start with low, okay? So low d high minus high d low all over low low, okay? Or all over what's below squared. Alright, so that's just a mnemonic device that some students find helpful in helping them remember what the quotient rule is. Okay, so this is just another way of writing vu prime minus uv prime over v square. Alright, so we have the formula in two formats. We're going to go ahead and apply it to this problem. So we have the derivative of x plus 1 divided by x squared plus 1. So we have v u prime, or low d high. So v, we already identified v as x squared plus 1. So we have x squared plus 1 times u prime, or d high. So we have, I'm just going to put that in bracket, x plus 1 prime, okay, minus uv prime, the numerator, x plus 1, times the derivative of the denominator, that's the low, x squared plus 1 prime. This entire expression divided by low square, or the square of what's below, however you want to call it. Okay, so what's below is x squared plus 1, or v. So we're going to square that, x squared plus 1 quantity square. Bam. Okay, so v u prime plus uv prime over v square. Now let's go ahead and carry out our differentiation where applicable. We have x squared plus 1, and then we're going to carry out term by term differentiation here. The derivative of x is just 1, and the derivative of 1 is 0. So it's 1 plus 0 minus x plus 1. Term by term differentiation here again. We apply the power rule to x squared, so that becomes 2x, and then the constant rule to 1 again, and that's 0. That divided by the denominator square, which is x squared plus 1 square. Okay, so we're done executing step 4. which is applying the formula to the problem. Now to finish things off, we're just going to refine or simplify our result. Okay, so we have x squared plus 1 times 1 is just x squared plus 1 minus x squared, let's write this as x plus 1 times 2x. Just add an additional step because I want to highlight something that's very important. Now, when you're presented a problem like this on the AP exam and you have um, polynomial terms to the right of the minus sign, you want to proceed with caution. A common mistake that students make is that they distribute everything and they forget the negativity here. Alright? So if you do this correctly, you're going to have negative 2x squared, and this minus changes this to a minus. So don't forget to distribute the minus. Okay, so minus times plus is minus 2x. So that's a common mistake that students make. If a question like this is on the AP exam, there's a 99% chance that this error will be included to trap students that are not paying attention. So don't forget to distribute your negative signs. Very important. Okay, in the denominator we have x squared plus 1 squared. We have two like terms that can be combined. In the numerator, x squared minus 2x squared is negative x squared. We want to write this in standard form, minus 2x plus 1. All that divided by x squared plus 1 squared. And ladies and gentlemen, that's the final answer. Okay, so d dx, the derivative with respect to x of x plus 1 over x squared plus 1 is negative x squared minus 2x plus 1 divided by the quantity x squared plus 1 quantity squared. Alright, so that's the final answer. Alright, let's take a look at the last question. So this will involve numerical computation of the derivative at a specific point. So let's say we have this table right here, and let's consider the following question. If we have a function, let's call it h of x, if h of x is equal to 2 times f of x divided by g of x, then the slope of the tangent line to h of x at x equals negative 1 is what? Okay, so this is the question that we are going to be considering now. Alright, so how do you compute the slope of the tangent line? You might be wondering, this is a differentiation presentation, so why are we talking about the slope of the tangent line? Well, guess what? The slope of the tangent line and the derivative of differentiation procedure are basically the same thing. Okay? So to solve this problem, let me just, or you can restate the question in a way that makes the procedure or processes that will enable you to get the answer obvious. That will be beneficial. Okay? So let's go ahead and do that. We're going to restate the problem in a way that reveals the process that we need to follow to get the desired result. So the slope of the tangent line is the same thing as, is equivalent to the derivative. So the slope of a tangent line is the derivative, okay? But the slope of the tangent line at a particular point, in this case x equals negative 1, is basically the derivative of the function at -1. So this is what the problem is asking us to find. Okay, this is much easier to handle, right? So h prime of -1 is the same thing as the slope of the tangent line at x equals -1. So to do this, remember we talked about this in the previous presentation. Whenever you're looking for the derivative at a point, it's a 2-in-1 problem. So you always want to break it up. Part 1, you want to find the derivative at any point. Step 1. And then step 2, you do the algebraic component, which is evaluate the derivative at a specific or the specified point. Alright, so remember you do your calculus first before you do your algebra. Okay, so let's do this. We're going to start with step 1, which is the determination of the derivative of the function. So let's find, what are we looking for? H prime of x, the derivative of the function anywhere. Okay, so we have h of x equals 2 f of x over g of x. Now if we think about step 1, manipulating this or rewriting it to avoid using the quotient rule, that's impossible here because we do not know what f and g are, so we can alter them with any algebraic rules or trigonometric identities that we know. So bottom line, we're stuck here. We have to use the quotient rule. Alright, so let's label it. The numerator function is u, and the denominator function is v. Don't forget to write down the formula before you apply it so you don't make any mistakes. U over v prime as what? Is vu prime. Remember, you always start with low d high minus uv prime. So vu prime minus uv prime all over low or v square. Bam. Alright, so there goes the quotient rule. We are now going to apply it here. Note that 2f of x is u, okay? There's another way that this can be done, but let's just do it this way right now. Alright, so we want to find the derivative h prime of x. The next step is to apply the formula to this situation here. So we have, what do we have? V, which is g of x, times u prime, which is 2 times f of x prime. That's vu prime minus u. U is 2 times f of x. So that's u v prime. V prime is g of x prime. Okay, and we divide it by v squared, the denominator square, which is g of x. Okay, so we square that. Alright, so let's just rewrite this just for cosmetics and to make the determination of the different values at specific points obvious. So h prime of x is going to be, now whenever you're differentiating and you have a constant being a multiple of the function you're differentiating, you can always factor out that constant. Okay? Constant multiple rule. So factor out a 2, so 2 times g of x. Now the quantity f of x prime can be written as f prime of x. Alright, it's the chain rule, but we're not going to go there right now. We don't have any inner functions, so we just do f prime of x and just stop there. And then we have 2 f of x. The quantity g of x prime is the same thing as g prime of x. And then that's divided by the denominator square. The function g of x square. Alright, we are done with part 1, which is to find h prime of x. So we still have another part 2 of the problem, which is to evaluate that derivative at a specified x value, namely -1. Okay, so I just copied the table down here because we're going to need it to do this problem. So h prime of 1, what does that mean? So if you think back to pre-calc and algebra, h prime of 1 basically means you're evaluating the derivative at negative 1. Or in other words, replace all the x's with what? Negative 1. Okay, so you have 2g of negative 1 times f prime of negative 1 minus 2f of negative 1 times g of negative 1, sorry, g prime, gotta be careful, g prime of negative 1 divided by g of 1, negative 1 square. Okay, so you can look at this as a big puzzle. All you just have to do is use your chart to find the puzzle pieces, and then you just insert them in their respective positions, and you are good to go. Okay, all right, so let's start with let me see, which one do we want to start with? Let's start with g of negative 1. G of negative 1. So if you look at this table, all you just want to do is you want to look for the intersection of g and negative 1. So this value right here, this g and negative 1, this, ladies and gentlemen, is what g of negative 1 is. So g of negative 1 is 1. Bam. Next, f prime of negative 1. So let's identify the f prime column. This is the f prime column right here. So we're going to be looking for the one that has the row of negative 1. So this right here, that's f prime of negative 1. Okay, so this is f prime of negative 1, and the answer is negative 2. Next, what are we looking for next? F of negative 1. So we have the f column here. So we're looking for where it intersects with the negative 1 input row. So that's it right here, to intersect here. So this value is what f of negative 1 is. All right. So we're just using the table to find the puzzle pieces. So f of negative 1 is equal to 3. One last thing to find is g prime of negative 1. So you have the g prime column, that's the last one here, and we need the negative 1 row. We want the same row the whole time, huh? So anyway, this guy right here, that's g prime of negative 1. So g prime of negative 1 is equal to 1. Okay, so we'll just substitute these numerical values in here, and it will be an order of operations problem. Please excuse my dear Aunt Sally. So let's carry out the substitution and then simplify using the appropriate arithmetic procedures. So we have 2 times g of negative 1 is 1. Let me put in parentheses. F of negative 1 is negative 2 minus 2 times f of negative 1. F of negative 1 is 3. F prime of negative 1 is negative 2. And then g prime of 1 is 1. And this entire thing divided by g of negative 1 square. G of negative 1 is 1, so it's just 1 square. Okay, so what does this become? 2 times negative 2 is negative 4 minus 6 over 1, which is equal to negative 10. Okay, so that's h prime of negative 1. Alright, so let's write down what the answer means. The slope of the tangent line to h of x at x equals negative 1 is negative 10. That's your answer right there. Okay, so don't forget the slope of the tangent line, STL, is the same thing as the derivative at that point. So how well did you master the contents of this presentation? Well, let's see. We'd like you to try the following problems. So let's try these problems out. Number 1, if g of theta is equal to cosine theta over theta cubed. Find g prime of theta. Okay. Question 2. I'd like you to find the derivative with respect to x of x squared plus 3x plus 2 divided by x squared minus 1. Okay? And then lastly, this will involve using a table. So given this table right here, if f of x, let's change that. If uppercase f of x, if big F of x is equal to 3x plus cosine 3x, 3x plus cosine x. This table is the same one as the previous problem, okay? Cosine x divided by f of x. Question is, what is the slope of the tangent line? What is the slope of the tangent line to big F of x at x equals 0? So what is it? Alright, so you can pause the video at this time. Go ahead and solve these 3 problems, and I will be showing you what the answer is momentarily. Alright, so let's assume that you've gone through the problems, you solved them all. Now these are the answers. Answer to question number 1, g prime of theta is equal to negative of theta sine theta plus 3 cosine theta divided by theta raised to the 4th power. So just note that this minus is factored out of the numerator. Okay, if you have it distributed into the numerator, your answer will be negative theta sine theta minus 3 cosine theta. That's the same thing. Okay, but if you factor out the negative, these two become positive. All right, that's the answer to question 1. For question 2, the derivative is negative 3 over the quantity x minus 1 square. And then for number 3, the slope of a tangent line, another way you can write it, of course, is f prime of 0 is equal to negative 5. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your studies of the quotient rule for differentiation, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about the presentation or the problems that we presented, just place it in the comment section below and we'll be more than glad to support you. Don't forget to subscribe to our channel for updates to other tutorials such as this. More clips can be found on mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.